All right, we're going to look at factoring, the greatest common factor, otherwise known as a GCF, greatest common factor. But before we get started, we want to do a quick review of the distributive property. Okay, and the reason for this is that when we distribute, we're going to get an answer, all combined with no parentheses, and when we factor, we're going to take that apart and get back to what it was before we distributed. So let's take a look at these two problems first as a quick review of our distributive property. We're going to take 3 and multiply it by x, okay, and we're going to get 3x. Then we distribute our 3 and we multiply it by a minus 4 or a negative 4, which makes it minus 12. And that's our final answer. So that's our distributive property. Very simple with numbers, binomial, very quick and easy. Now let's take a look at our next one down here, which is 2x times the quantity of 2x squared minus 1. We're going to distribute the 2x, and we're going to get 4. And the x times x squared, remember there's a power of 1 on this x. And when you are multiplying like bases, you keep your base, so they keep the x. We add the exponents, 1 plus 2, so we get 3. So this becomes 4x cubed. So 2x times 2x squared is 4x cubed. Now we're going to do 2x times a minus 1, and we're going to get minus again, and it's 2x. And you don't have to put the power of 1 on that. That's okay to leave it that way, but if it makes you comfortable for a while, you can. And that's our answers to our distributive property as a quick review. I'm going to put these to the side here, and we're going to start on our next problem, okay, which is to start learning how to factor the greatest common factor. Okay? All right, the greatest common factor. A couple of notes here. 1, you want to factor out the greatest or largest number. So when we say greatest, we mean largest in math. So I'm going to put that in parentheses. Largest number that can be divided into both terms or all terms. Okay, so that's important. Factor out the greatest or largest number that can be divided into all terms. Now, when we're dividing it, we're actually taking it out, so we're not losing it. So we have 3x and we have 12. Well, 3 times x is 3x, and 3 times 4 is 12, so obviously we have a 3 that can be factored out. Now, this step that I'm doing in red, we don't do all the time. We kind of think about it and we just go with it, but just want you to see how it was broken down. So I'm going to factor out the 3, which means I bring it out and I immediately open up parentheses. You don't have to close them yet, but since I know there's only going to be 2 terms left, it doesn't have to be a long set of parentheses. So 3 divided into 3x. Okay, so what we're really going to do is divide 3 into 3x. So I'm going to do this on the side. 3 over 3 is 1. That leaves us with x. And check it. 3 times x is 3x. 3 divided into 12 is 4. And check it. 3 times 4 is 12. And we have taken the distributed answer that we had, 3x minus 12, and we've factored out and put it back into what it would have been before we multiplied, before we distributed. So we get back 3 times the quantity of x minus 4. That's factoring. 3 is the greatest common factor, and we can't lose the value of the 3x minus 12. We can't change this. We're just going to make it look different. So we have 3 times the quantity x minus 4, which is still 3x minus 12. Okay, it's the same thing, but in a different form. That's factoring using the greatest common factor. I'm going to still keep this here. We're going to look at our next problem. Now, as you can see, our second problem for distributive property, we got 4x cubed minus 2x. Well, let's take that 4x cubed minus 2x, and we're going to pull it apart. We're going to factor it. We're going to take out the greatest common factor, which is always the first thing you should look at. So first step is we factor out the greatest or largest number that can be divided into all of our terms. So 2 can be divided into 4 and into 2, so we're going to take that out. But there's a second step here that we have to do. And that second step now involves the variables. If the variable appears in all the terms, it has to come out as a factor. So we factor it out. All right, so what does that mean? X cubed and x. So I see x in all my terms here. And because I see it all my terms, I have to take it out. I immediately open up my parentheses. That way I know that I'm done factoring out. Now, the second part of this step, it's a big and. Take the lowest power, lowest exponent, lowest power. Remember, exponent is our powers. Okay? Well, if we look here, we have an x cubed, and this one is an x to the first power. Put it there if you need to see it. It's perfectly fine. Okay? And we're going to only take out x to the first power because it's the lowest or smallest power that we see in the problem. Okay. Now, we're taking 2 divided into 4, and we're getting 2. If we take x and divide it into x cubed, remember our division rules, we're going to subtract the 1 up here, get rid of that x, and that's x squared. Okay? Another way I look at it is this. If I took 1 power away from 3 powers of x, I have 2 powers of x. All right, next. 2 divided into 2 is 1. X divided into itself is 1, so we just have 1 there and we're done. Checking. 2x times 2x squared is going to be 4x cubed. And 2x times the minus 1 is going to be minus 2x. So that's your check. So this is the factored form. In other words, back to what we had before we multiplied it and distributed to get 4x cubed minus 2x. So that's our factored form. Our greatest common factor is 2x, and the binomial, which is the rest of what's left, is 2x squared minus 1. All right, so we're going to keep these directions here because these are important for us to do all these problems. All right. All right, let's take a look at this one. Kind of looks the same, but it's not. So number 1 rule, factor out the greatest or largest number that can be divided into all terms. So I've got 4x cubed minus 2x squared. I can take out a 2. Next, I want to take out a variable if it appears in all the terms. X appears in all the terms, I'm going to take it. I'm going to take the lowest exponent that I see, cubed and squared. So squared is the lowest. I take out 2x squared, open my parens. 2 divided into 4 is 2. If I take 2 powers away from 3 powers of x, I have 1 power of x left. So x to the first. Minus 2 divided into 2 is 1. X squared divided into x squared is 1, so I am done. And this is our answer in factored form. 2x squared is the GCF, and 2x minus 1 is the rest of what we need in order to keep this the same, just in a different form. Okay, so let's now look at this next problem, okay? 4x squared b minus 6ab cubed minus 8a cubed b squared. We're going to follow the exact same rules. All right, we're going to factor out the greatest or largest number that can be divided into all terms. So 4, 6, and 8. Common factor is 2. That's the highest number we can divide cleanly into 4, 6, and 8. Next, if a variable is in all the terms, factor it out. A squared, a, and a cubed. A is in all the terms, we're going to take it out. We're going to take the lowest exponent of a. That's a square. This one's a 1, so write it if you don't see it. And this is a cubed, so a 3. The lowest power we're going to take is a 1, and I'm going to write it here so we can just see it. We also have b cubed, b squared. So b is in every single term. So we're going to take b out also. So you work your variables independently. So this is b to the first. This is b cubed, b squared. The lowest power we see in this problem is b to the first, and that's it. All right, now we're dividing. 2 divided into 4 is 2. If we take 1 power of a from 2 powers of a, we have 1 power of a left. We take 1 power of b from 1 power of b, we have 0 powers left, and anything to the 0 power is 1. Or you can look at it as b to the first time divided by b to the first is 1. So there's nothing left there. So we don't need to write it because we already have a term 2 times a times 1 won't change to a. It will stay the same. Minus 2 divided into 6 is 3. A divided into itself is 1, so 3 times 1 keeps us with the 3. Taking 1 power of b from 3 powers of b gives us b squared. And we're done with the middle term. Last term. 2 divided into 8 is 4. Taking 1 power of a from 3 powers of a is a squared. And taking 1 power of b from 2 powers of b leaves us with b to the first. You can leave your answer like this with your first powers, or you can rewrite it as a 2ab and leave the powers off because they are there, times the quantity of 2a minus 3b squared minus 4a squared b. And that's our answer. So that's our factored GCF is 2ab, and here is the rest of our factor so that we get back our 4a cubed b minus 6ab cubed minus 8a cubed b squared if we were to multiply it out again. So that's how you should check, is to distribute this back in and see that you get your original problem back. All right, next. I'm going to go through this a little bit quicker. We have 3x cubed y plus 6x squared y squared minus 12xy. Okay, the highest number that we can take out for the factor for 3, 6, and 12 is 3. X cubed, x squared, and x, I can take an x out because it's in all terms. The lowest power is 1, which is on this one here. Y squared, and y, I can take a y out. The lowest power is 1, and this one's also a 1. So I'll take the power of 1 out. That's it. 3 into 3 is 1. X to the first divided into x cubed. 1 power taken from 3 powers leaves us x squared. And y divided by y is 1, so we don't have to write anything here because it won't change 1x squared. Plus 3 divided into 6 is 2. 1 power of x from 2 powers of x leaves us 1 power of x. 1 power of y from 2 powers of y leaves us 1 power of y. And we're done with that term. 3 divided into 12 is 4. 1 power of x from 1 power of x is 0 power. Anything to 0 power is 1, so 4 times 1 is still 4. Or you could look at it as x divided by x is still 1. Y divided by y is 1, so 4 times 1 is still 4, and we leave it like that. So if we want to rewrite it without all these 1 powers, we could also say it's 3xy times the quantity of x squared plus 2xy minus 4. So remember, as you're factoring out, sometimes you won't have any more x's or y's or other variables in your terms because you factored them out and they're now here. Good way to check is to distribute back in and get back your answer, and then you know you are correct. All right, and the last problem. 3x to the fourth y cubed minus 6x squared plus 12x cubed y squared. All right, we can take a 3 out of this because it's 3. Can divide into 3, 6, and 12 evenly. X appears in all the terms, so we'll take out x. And the lowest power we see is 4, 2, 3, so it's a 2. So we take out x squared. Y cubed is in this term. There is no y in this term, so we can't take y out. We can stop looking. That's it. 3 divides into 3 once. 2 powers of x from 4 powers of x leaves us 2 powers on the x. And we did not touch the y cubed. No division there, so we keep it. Right? All right, next. 3 divides into 6 2 times. X squared divides into itself once, so 2 times 1 is still 2. And we're done with that term. There's no more x in that term. 3 divides into 12, 4. 2 powers from 3 powers of x gives us 1 power of x. And we don't have a y to divide into, so the y squared stays. So if you don't want the power of 1 here or the coefficient to show, you can write it as 3x squared times the quantity of x squared y minus 2 plus 4x y squared. And that either of these are 2 acceptable answers. You can show your powers and coefficient of 1 if you want, or you don't have to. That is how you factor using the greatest common factor. And then again, to check, you multiply back in and make sure you get back your original. Keep these rules nearby because these are what you're going to use every time you are trying to do the factoring. And over time, you'll just know how to do it. It'll become common sense and kind of a rote memory skill.